Hello, in this video we're going to look at solving radical equations. So when solving radical equations, ultimately I'm doing what I'm doing when I'm solving any equation, which is I'm trying to isolate x. So starting with operations that are the outside operations, essentially furthest away from x, I work my way in. So in this case, for example, I would subtract 3 first. So I get negative square root of 2x minus 9 equals negative 2. I am going to actually multiply both sides by negative 1 here, so I get the square root of 2x minus 9 equals 2. That's not actually strictly necessary because this next step is to square both sides, so whether both sides were positive or both sides were negative, squaring is going to accomplish the same thing. But when I square both sides here, I get 2x minus 9 equals 4, which means that 2x equals 13, and therefore x would be 13 over 2. We do have with radical equations the opportunity for something to occur which is called an extraneous root. So extraneous roots are solutions that show up through correct algebra, but when we check them in the original equation, they don't actually work. So we have to check everyone. The reason this happens is because every number has two square roots. It has a principal root and a negative root. In this equation, for example, we're using the negative root, but in a different equation that used the principal root, I would actually come up with this exact same answer, but this answer only works in one of the two. So in class, I'll go over sort of a visual explanation a little bit more about why this happens, but the upshot of it is, the takeaway is, we absolutely have to check our solutions for rational equations, or radical equations, my mistake, sorry. So I have to consider, does 3 minus the square root of 2 times 13 over 2 minus 9 actually equal 1? So this is 3 minus the square root of 13 minus 9, which is 3 minus the square root of 4, which is 3 minus 2, which is 1. So in this case, it works, and that solution is correct. But if we look at this next example, again, working my way in, I'm going to subtract the 5 first. So I get the square root of x plus 1 equals negative 3. Now, at this moment, alarm bells might be going off in your head. You might be like, wait a second. We'll come back to that in a moment. But I'm going to carry on as if I don't notice that there is something potentially wrong here. And if you don't notice, then that's fine too. We'll come back and explain it. But when I square both sides, I get x plus 1 equals 9, which means x equals 8. Nothing wrong in my algebra. That is a perfectly acceptable solution. But when I check it, 5 plus the square root of 8 plus 1, this is 5 plus the square root of 9, which is 5 plus 3, which is not equal to 2. So this actually is not a valid solution. X cannot equal 8, and there is no solution to this equation. This happens, we can see, because if I were to actually have used the opposite root here, so if this had been 5 minus the square root of x plus 1, and this would be a minus here, and minus, minus, then 5 minus 3 would have equaled 2. But it doesn't in this case, so we have no solution. Now, you may have noticed right from this step that there was going to be no solution, and that's fine if you notice it, that the square root of x plus 1 has to be positive. So it can never equal negative 3. So at this point, you might notice that it's impossible and stop there, and that is okay. For cubed roots, we don't have this issue because we don't have a principal and a negative cubed root, but our process is the same. So I'm going to subtract the 5, and I get that the cube root of 2x plus 4 equals negative 2. But this is not a problem for a cubed root in the way it would be for a square root, because I can have a negative cubed root. So this means that the 2x plus 4 is equal to negative 2 cubed, which is negative 8. 2x equals negative 12. X equals negative 6. Now, you don't have the potential for extraneous roots here, but it's still not a terrible habit to check your answers. So 5 plus the cubed root of 2 times negative 6 plus 4 is negative 8. This is 5 plus negative 2, which is in fact 3. So that works out.